Hello again. On this video for a quiz problem in a way in the similar fashion in a similar way that I did the fourth root, I'd like you to find the derivative dy by dx when y equals the fifth root of x. And you'll have to go through motions that are similar in nature to the fourth root. Of course, the only difference is you're going to have the fifth root prototype instead of the fourth root prototype. But anyway, that's a quiz problem for you to do. And again, we can do the derivative of other trig functions. This one I may skip. Like here I do the derivative of the secant of x. And you just go through and you have to do some... Well, I said I'd skip it, or I'll go through it. How about I go through it quickly instead? How about that? You write the secant as 1 over the cosine. So here's f of x plus delta x minus f of x over delta x. And you write secant as 1 over cosine. By definition, that's what secant is. And then you get common denominator. And then you bring this denominator down and multiply it distributively across delta x. Wait, no. Never mind. There's no distributive here. No, you just multiply it by delta x. And actually, it's a very nice multiply. There's no distributivity there. Sorry, my bad. So there's that. So you just bring this guy down onto the delta x. And so that you get that. And now by the laws of trigonometry, you have to turn cosine of x plus delta x into cos minus sin. But this minus sign is going to hit what would have been a minus sign here and make this a plus sign right here, okay? So watch out for that. And so now we keep these cosine terms together. We factor out cosine x, and that leaves 1 minus cosine delta x here. Keep the sin term over here. We have the same old denominator for the time being. And then scroll on down. Now you break this apart. This plus sign right here is going to mark a rift. So you're going to separate the two limits. And then you're going to do some cancellations, you can bet. Well, actually, you know what? Well, let's see. You know what, guys? You see that delta x? We can take him out to the side. What did I do here? Oh, the cosine, yeah. The cosine x and cosine x cancel. You see this cosine x here and this one here? They divide off. So we just get 1 minus cosine delta x liberated over just delta x cosine of this entity, x plus delta x. Okay, and then plus, now this guy right here, well, we can't really get rid of sine and cosine. That would create, sine over cosine is tan of x. You can erase sine and cosine and put tan up here because sine x over cosine x is tan x. And that's okay. We may go there in a minute. But what I opt to do instead is I break these apart, like so. The limit of the product is the product of the limits. Now with the restraint though, you got to keep the 1 minus cosine over delta x together because this is a 0 over 0 form. If you can't throw delta x directly in just yet. Well, actually, yeah, you can't throw it in at all. But we know from prior comments that this limit is 0, which is going to blast off whatever anyway. So 0 times whatever is 0. This limit right here, well, that's going to be it'll be 1 over cosine x, but it's going to get killed by this 0 right here. So this term goes bye-bye. We know that this limit is 1, so we can ignore it. It doesn't affect anything. It's of no effect. And then so we will be left with this limit here that we'll have to contend with right here. So this guy is, we can ignore everybody but this limit right here. Okay, and as it turns out, hey, we have continuity now. We can just throw delta x in here. You know what? I actually could have done that up here, but oh well. No, I couldn't have. Well, yeah, sure. Could I? No, not really. I need to do this. So never mind that. I need to do this. So then throw delta x, 0 into delta x, and you just get sine x over cosine x cosine x. So it's a sine x over cosine squared of x. That's good, but there's a much prettier way to write that. Sine over, notice that this can be thought of as sine over cosine times 1 over cosine. The sine over cosine is the tan. The 1 over cosine is the secant. And this is the classic way to write it, is Secant. Please do so. Even though this is technically correct, this is more elucidating because you'll see this in science or math classes that you'll take. Secant x tan x, okay? So there's that. So the derivative of the secant is the secant times the tangent, or the secant tan. So I did go through it after all. Now here's a tricky one. It's a rational rational expression, or y equals a rational expression or whatever, but it's not particularly nice. Guys, if we're going to do the derivative of y when y equals 7x over 4 minus 5x, it's a little frustrating. Here's what you do. We write that first off as 7 over negative 5x plus 4 by commutativity. And now I can yank a negative out. What it is the negation of negative 5x plus 4 is positive 5x minus 4. I take negative 1 out here. I change the negative 5x to a positive 5x. I change the positive 4 to a negative 4. Okay, like this. Okay, so what of it? So I get, well, notice that, scrolling back up, this can be thought of as negative 7x times, parentheses, 5x minus 4 to the negative 1 power. That's what the negative 1 power means, is divide right here. And our domain can be anybody but 4/5. Obviously, we don't want 4/5 to go here. You know, we'd get 0 on the bottom. But any other number is fine. Any other real number. So we have, so y equals this. Now I'm going to do some more tricks before I break in and do the derivative, which equals, now this can be thought of as, you know what, the derivative of 5x minus 4, well, no, not really. Let's not do that. It would be nice if I could, let's see what I do, and then I'll talk about the big picture. So I insert a negative 7/5 here times 5x. After all, negative 7x can be thought of, or in particular, just negative 7 can be thought of as negative 7/5 times 5. But in associativity, you know, we have all that here. So negative 7x can be thought of as negative 7/5 times 5x. Now, let's see, what's my motive? I insert a plus 4 in here. But that's okay, but I have to counteract negative 7/5 times 4. This is distributive here. Across this negative 7/5 hits this guy and this guy. So negative 7/5 times positive 4 has to be counteracted with positive 7/5 times positive 4. This term right here, the purpose of this term is to counteract this term. Notice that what I'm, let's see. What am I going for here, though? So I have negative 7/5 5x plus 4, and then plus negative. Notice this can be thought of as negative 7/5 times negative 4, and so what's my motive? So, I can now notice that both of these guys are now negative 7/5. So I can bring these all in together as negative 7/5 is distributed across the 5x, the plus 4, and the minus 4. So the negative 7/5, now the negative 7/5 can be brought out like this, and on the numerator I get 5x plus 4 minus 4 over 5x minus 4, and then so I get, but then, see that minus 4, by commutativity I can move the plus 4 over here and the minus 4 over here, so I get negative 7, and then I can break it up. The 5x minus 4 can break up, and then I can see this plus 4, I break it up as plus 4 over 5x minus 4. Whew. And then, but wait, 5x minus 4 over itself is just 1. That was my motive. Okay. I wanted to get 5x minus 4 up top, but I had to do some surgery to make that happen. Oh, okay. So that's 1, and then I get 1 plus that same old 4. Now this is just the price I got to pay here. I got that 4 over 5x minus 4. But it's better than having an x up there. Notice there's not an x this time, thankfully. Now if I distribute negative 7/5 through, negative 7/5 times 1 is negative 7/5. Negative 7/5 times positive that fraction, well, negative 7 times positive 4 is negative 28. And then I'll just call this positive 5 down here. Positive 5 distributed over 5x minus 4 is 5 times 5x is 25x. 5 times negative 4 is negative 20. distributive there. So I'll multiply 5, this 5 by this. And I take this minus sign and put it right here in the distributive. Okay. Now, okay, so now when I get now by commutativity, I can just move this guy to the left here and that minus 7/5 to the right. That's by commutativity. Why did I want to do all that though? Okay, why did I want to go through all that hassle? I didn't have to do this, but I wanted to do it in order to shorten my difference quotient. So, okay. So we have dy by dx is the limit of this new guy minus, well, the new guy relative to x plus delta x minus the new guy relative to just x. So this is f of x plus delta x minus f of x over delta x. And then, well, what do I do? Okay. You see this delta x, guys? You can bring him up here distributively, denominator distributive. You can put him up here with the beside the 25. You could say delta x times 25, or you could say 25 delta x. And then you're going to also put the delta x beside the 5. You'll have 5 delta x. You'll put the delta x. Now he'll distribute across these two guys right here and here. So you do delta x parentheses times this binomial right here, and then a 5 delta x here again. So you bring delta x in each of these denominators here, 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 and here. And that's what I do. So here it is, here it is, here it is, here it is. Oh wow, that just prevents me from having a fraction within a fraction, which is always annoying. Okay, so now what do I do? Hey guys, you know what? This is a negative 7 over 5 delta x, and then minus a negative, which is a plus a positive 7 over 5 delta x. This term here and this term here are going to cancel. So I'm just left with negative 28 over this stuff right here. And then this is a minus a negative. Well, no, wait. No, I ignore that minus sign now. Hold on. Yikes. It's screwing up on me. So I have a minus sign here. Now this is start here, okay? Minus a negative is plus a positive, so it's plus 28 over this term right here. So the 25, the delta x, the 25x minus 20, and all that. So I have that, and right there. So there's that. And you know what? That 5 shouldn't be there, should it? Okay, sorry about that, guys. That 5 should not have been there. And actually, I didn't put the... Yeah, that's... Okay, that's good. So I can do that. Actually, yeah, yes, that 5 should be there. My bad. Yeah, it should. I had it right the first time. Because what I did, you see that 25x minus 20? I factor out 5 and I get 5x minus 4. My bad. I had a brain meltdown there. See, that was 25x minus 20 up here. Now it's 5x minus 4 because I factored out that 5 there. So yeah, that 5 does belong. My bad. Okay, and so I reinserted it there. Now, what I can do, 28's common to both numerators, and what I do is I factor out negative 28, which is going to make this a positive and this a negative. So that I just get a 1 here and a 1 here. Well, with a minus sign now here. And then I factor out a 5 on the bottom, so that's negative 28 up top and a positive 5 on the bottom I factor out. That's going to take these 5s here and here off the denominators, so that just leaves just the numerators without the 5s. Okay, like that and that. And then what do I do next? I have got to do the painful thing I've been dreading and get common denominator. The price has to be paid eventually. So the common denominator, they both have delta x's in them, so it'd be silly to do anything with delta x. But notice I need 5x minus 4 here, and I need 5 times this. I need 5 times this guy minus 4 here, the more complicated one here. And then what I do, notice since you put a 5x minus 4 up here, you got to stick one down here. And since you had 5 parentheses this guy minus 4 here, you've got to have the same thing down here. And when I say this guy, I mean 5 parentheses, or, well, when I say this guy, I mean x plus delta x. But anyway, so you have to insert this here, and you have to put either, you can use, I use brackets, you got to use parentheses or brackets or something, because you're multiplying this times the whole thing this times the whole thing this. And in similar fashion, you're doing on this other one, you're doing this times the whole thing this times the whole thing this. But notice our denominators are the same now, because by commutativity, it doesn't matter what order I multiply them in. So I have the delta x, I have the 5 distributed over x plus delta x, and then separately minus 4. I have the 5x minus 4, and I have all that here. Nothing else, or nothing less, nothing more. So my denominators are the same, thank heaven. So I can bring this together carefully, though. Now this 5x minus 4 is good to go. But then now this minus sign means I'm going to have minus 5 times distributed over this guy, and then minus a negative 4 is a plus 4 here. Be really careful with those negative signs over the same common denominator. But anyway, and then so I get negative 28 fifths. Now let's do that distributed. It's not too painful. 5x minus 4, now negative 5x, and then another negative 5 times delta x, so it's minus 5x minus 5 delta x, and then that plus 4. Okay, so there we go. Now after that, that negative 4 there and that positive 4 are going to cancel. Not only that, the 5x and the minus 5x are going to cancel. All that's going to live and remain is the negative 5 delta x upstairs. Well, I'm talking about all that remains upstairs. Now we still have the stuff on the bottom. So all that survives relative to the upstairs is the negative 5 delta x. That's understood to be negative 5 times delta x. Okay, over the stuff on the bottom, and we still got this multiplier of negative 28 fifths. Remember, the limit of a constant times a function is the constant times the limit of the function. So this negative 28 fifths is just dangling multiplicatively out here. But what do I do next? Oh, you see this negative here and this negative here? They cancel. Negative times negative is positive, so we can kill this negative and this negative. They each kill each other. So we're just left with positive 28 fifths times positive. And what? Oh, another thing I can do now. Oh, this delta x is vulnerable because there's no adding and subtracting going on. This delta x here will cancel this delta x down here. So the negatives cancel, the delta x's cancel, and I'm left with a pretty positive 5 up here. That's always nice. Over this bottom guy here. But then delta x is warden to 0. So, since the delta x's have died, anytime you divide off the delta x's, you can usually go ahead and throw in 0 for your delta x. So, if not always, usually. I want to say always, but I might come back to you later on that one. But for our purposes, always, or almost always. But anyway, so these delta x's cancel, and indeed you can throw 0 into delta x with total safety. So you just get 5x minus 4. Hey guys, this is 5x minus 4 because this delta x is dead. It's 0. So you just get 5x minus 4 times another 5x minus 4, which is 5x minus 4 squared. So we get 28 fifths times 5 over quantity 5x minus 4 squared. But remember, by the law of fractions, this 5 right here and this 5 right here are going to cancel. And this 28 can just come up, and 28 times this 1 that's left over, 28 times 1 is 28. So it's just 28 over the square of 5x minus 4. Or if you want to write it in exponent form, you don't have to do this last step necessarily, unless your professor, he or she, just insists on it. That's 28 times, parentheses, 5x minus 4 raised to the negative 2 power. Again, we're only raising the 5x minus 4 to the negative 2 power, not the 28. The 28's sort of by itself. You know, it's multiplying this term right here. But anyway, so it's 28 times the negative 2 power of 5x minus 4. Okay. I'm out of time, guys. Thank you. I'll see you on the next video.